In the previous sessions, we have looked at geometric progression. We have looked at geometric series. We have seen the nature of R and its impact on the progression as well as on the series. Look at a couple of examples of geometric series. So let's say we have 1, 2 by 3, 4 by 9 and so on. And we have to figure out sum of first 5 terms and the sum when we take it to infinity. Okay, let's see. Now this sequence can be written as 2 by 3 to the power of 0, 2 by 3 to the power of 1, 2 by 3 to the power of 2, 2 by 3 cube, and so on. So here A is equal to 1. There is nothing here, so it is 1. And the common ratio is equal to 2 by 3. Now that means the magnitude of R is less than 1. And in the previous session, we had seen that if the magnitude of R is less than 1, the series converges to a finite value. So, which means we can apply this formula. S sub n is equal to A times R to the power of n minus 1 by R minus 1. So, let's apply that. We have S sub 5 is equal to 1 time A is 1 times R to the power of n 2 by 3 to the power of 5 minus 1 divided by 2 by 3 minus 1. It's just a question of simplifying it. So we have 2 to the power of 5 is 32, 3 to the power of 5 is 243 minus 1 divided by 2 minus 3 by 3, that is minus 1 by 3. Let's bring this to the numerator. We get minus 3 times 32 minus 243 by 243. Simplifying it, and we get S5 is equal to 211 by 81. So we have found the first. Now we have to find the second, that is S to infinity. So S sub infinity is equal to, again we know this formula, A by 1 minus R. So doing the substitution, we get A is 1 divided by 1 minus 2 by 3, which is equal to 1 by 3 minus 2 by 3, which gives us 3 by 1, which is 3. That means this series, if we add all the terms of this progression to infinity, we get 3. Let's look at another example. Here A is equal to 2 and R is equal to 3 by 2. Immediately you must have noticed the difference. So it starts with 2, 2 times 3 by 2, 2 times 3 by 2 square, 2 times 3 by 2 cube, and so on. And this can be simplified to 2, 3, 9 by 2, 27 by 4, and so on. Now here the important thing is that the common ratio, the magnitude of it, is greater than 1. So let's find the sum of first 5 terms. So S sub 5 is equal to 2 times 3 by 2 to the power of 5 minus 1 divided by 3 by 2 minus 1. If simplifying it, we get 211 by 8. Since the magnitude of R is greater than 1, that means the sum when taken to infinity will give us infinity. That is, a series diverges. Here the series converges to 3. You know, most of the times we get straightforward geometric series to figure out the value of. But sometimes we get a series that is not a geometric series. In such a case, we have to see if we can convert it into a geometric series. Let's see what we mean by that. Let's say we are given this series. S sub n is equal to 7 plus 77 plus 777 and so on up to n terms. Now, how do we figure out this? Yeah, pretty straightforward. We can say we just keep adding it up. But that's not very efficient, let's say. So let's manipulate this. 7 is common to all the terms. So take it out. We get 7 times 1 plus 11 plus 111 plus and so on up to n terms. Now, this is not a geometric series. So we have to do something else. So let's do one thing. Let's take out 1 by 9 as common factor. Now, if we take out 1 by 9 as a common factor, we get 7 by 9 times 9 plus 99 plus 999 plus and so on up to n terms. If you open up the bracket, this 9 will cancel with 1, 11. So we get back the original. Okay. What can we do with this? This is still not a geometric series. Let's write each of these terms as a difference. So 7 by 9 times 9 can be written as 10 minus 1. 99 can be written as 100 minus 1. So which means we can write it as 10 square minus 1. 999 can be written as 1000 minus 1, which is 10 cube minus 1 plus 10 to the power of 4 minus 1 and so on up to n terms. Now this is still not a geometric series. So let's see what else can we do. Let's open up the brackets. So I just opened up the brackets. Now let's group them. 7 by 9 times 10 plus 10 square plus 10 cube plus 10 to the power of 4 and so on up to n terms. That is 10 to the power of n. Minus is common to all the ones. So minus within brackets 1 plus 1 plus 1 up to n terms. Now, this is not a geometric series, but this is. Here, what is the common ratio? It is 1. So at least one geometric series we have got. Now we have to see what we can do with this. One of the things is the geometric series always starts with power of 0, r to the power of 0, that is 1. So let's make the first term as 1 by taking out 10. So we get 7 by 9 times 10. Now 10 we have to take it out of each of the terms. So we have 1 plus 10 plus 10 square plus 10 to the power of 3 plus and so on. And the last term in this will be 10 to the power of n minus 1. And 1 plus 1 plus 1 is nothing but n. Now we have a geometric series minus a constant. Remember, we know the formula. S sub n is equal to a times r to the power of n minus 1 by r minus 1. So let's apply that. So 7 by 9 times, now here is where the formula comes. 10 to the power of n minus 1 by 10 minus 1 minus n, which is equal to 7 by 9 times 10 times 10 to the power of n minus 1 by 9 minus n. So we have arrived at a formula. So the sum of first n terms in this is equal to this formula. Find the sum of the first 3 terms. So S sub 3 is equal to 7 by 9 times 10 to the power of 3 minus 1 by 9 minus 3. We get 7 by 9 times 10 to the power of 3 is 1000. 1000 minus 1 is 999. Divided by 9 is 111. Times 10 is 1110 minus 3, which is equal to 7 by 9 times 1107. Now here 9 ones 9, 2 remainder 20, 9 twos 18. 2 remainder, 27 9 threes. So we have 7 times 123, which is equal to 861. Now, the reason I took S sub 3, first three terms, is because we can manually add them up and verify it. 7 plus 7, 14 plus 7, 21. 1, 2. 7 plus 2, 9. 9 plus 7, 16. 16, 6, 1. 7 plus 1, 8. So that was an interesting example. If you found this session useful, don't forget to like, share, and subscribe. Questions, suggestions, and comments are always welcome. Thanks for watching. See you in the next session. That's it for now.